everyone. So, welcome to day 4 of Illuminate AI's 2022 conference. I really hope you guys enjoyed the last 3 days of the conference with all the speakers that we have had. So, today is the last day of the conference, and we have two more speakers. So, I wanted to introduce our first speaker now, who will be talking about quantum AI. And after the first session, in between both the sessions, we'll be having our trivia question similar to what we have been having in the last 3 days. So we'll see who's the fastest person to answer the question, and that person will be receiving between the spreadsheets by Susan Watch. So, yeah, without much ado, let me bring on Sanjay. Hi, Sanjay.
Hi.
It's nice to have you here.
Yeah, same here.
Thank you so much for agreeing to speak at the conference. And I wanted to just introduce Sanjay. He's presently a research software engineer at IBM Research in California, and he has a specialization in quantum computing. So, Sanjay, do you want to maybe talk a little more about your interests in quantum and how did you get into the field?
Yeah, so I have some reasons of getting into quantum computing because right now, by one of the primary reason was the machine learning and AI hardware because we are not able to like patch up with the current speed of software. So primarily, we have to look into like new architecture. So it seems like quantum computing is one of the promising hardware. So my one of the core reason was this, and maybe I have like some more reasons that I'll be covering up in the slide.
Awesome, that's awesome. So, uh, for the audience, he'll be starting the session soon. So, whenever you have any question, please feel free to put that in the comments. We will be taking pauses in between and try to answer your question through the presentation rather than pushing it to the end. So, that way you can get your questions answered sooner. And if you have any follow ups, you can ask that as well. So, yeah. So in the meanwhile, please let me know whoever has joined the call, so that we can just see which states are people joining in from, which country are people joining in from. So definitely put that in the chat. Awesome. So yeah, Sanjay, you can start with your session.
Yeah, so I'll start sharing my screen. So let me know if everyone is able to see my screen.
Yes, it's visible.
So yeah. So good morning, everyone. Let's begin the session. So as Ashwin has given my introduction, so again I'll just repeat myself. So I'm Sanjay Vishwakarma. I'm currently a research software engineer at IBM. I'm a Qiskit advocate as well and IBM Quantum ambassador. So today I'll be just presenting a quantum one-on-one session where I'll be covering a lot of different topics on quantum computing. So let's begin with a simple question. Like why do we need a quantum computing? So let me ask by a simple question. How many ways can I arrange a dinner party of 10 people? So common answer will be like 10 factorial, which will be like 10 into 9 to 10 into 1. And it will be like this many number of ways. So this problem seems to a very simple problem. And why do we need quantum computing for this? But what if I keep adding chairs to this table? So it will be like 11 factorial. And then if I add more chairs, it will be like 12 factorial. So every time I keep adding chairs to this table, the problem grows exponentially. And a problem that seems to be a simple problem converts to a complex problem that even classical computers are still trying to figure out. So some problems are bigger than you think. So, but you might be thinking about like we have still a powerful computers that can easily handle this big problem, right? So let me give you an example. We have like IBM supercomputer. We have this many number of bits of storage, which is still not enough to perfectly model a caffeine. So what is exactly a caffeine? So caffeine only has like 24 atoms, but modeling it requires a lot of power. Using a classical computers, perfectly modeling a classical caffeine would require 10 raised to 48 bits of storage. But the number of atoms that are present on the entire planet is like 10 raised to 49. So clearly we see an issue, right? So some problems are too small to clearly see. So where exactly quantum computing lives is the big and small. The duality of big and small is exactly where quantum computing lives. Classical computers follows the classical law of physics, whereas quantum computers follows the law of quantum mechanics. So quantum mechanics is basically how things behave on extremely small scale, which is very weird. So because of this, classical computers can tackle really big problems much more efficiently than how classical computers can. Now let's look at another angle why I am interested in quantum computing and why what is exactly the need of quantum computing. So if you look at a trend which is going on the current industry is like machine learning, deep learning, and everything is going on, right? but they are doubling at the rate of every 3.4 months. But if you look at the hardware, which is called as a Moore's law, we are able to double the hardware at every 24 months, which is 7x slower. So if we want to make up to the speed of the AI and machine learning training that we have right now, we have to catch up to a speed of like 500x per 3 years, which is like it will approximately take 10 years, 12 years, and more years, right? So if you think about the possible solutions for it, so if I was training a model with two GPUs, probably with the current speed, we have to like take four GPUs or six GPUs and train. So we need to buy like more NVIDIA GPUs and burn more power to it and train it, and with more training time, right? Or second solution will be to look at some powerful architectures rather than the classical computing. Second reason, data generation. We know like deep learning came into existence because of availability of data. It was like one of the core reason for bringing data. Like deep learning was there in the concept from a long decades, but it came into existence because of one of the reason was data. Today we generate like 2.5 quadrillions of data, but how to process this much amount of data with the current architecture? If someone wants the results in within few hours, we might our classical computers might not able to give the data to you like the expected results. Again, we have to look for some new architecture, and I believe like quantum computing is one of the promising architecture. Now, why even like quantum computing matters? Even though quantum computers are currently limited in certain ways, the potential remains guaranteed to create a new paradigm in how we solve problems. So quantum computing provides us three reasons. So first is like new algorithms. We have like a lot of algorithms like Grover's algorithms and everything. We have like new approaches to the problem, and we have like new technological breakthroughs. So um, I'll talk about like what is qubit and why it is special. We have like for classical computings, we have like bits, right? We have like zeros and one, we call it as bit. But in quantum computer, we call it as a qubit. And now this qubit comes from a quantum bit of data. So we have taken the q and we have taken the bit. So that's why it is called qubit. So in terms of classical computings, we call it as a bit, but in quantum computing, we call it as a qubit. So qubit have like many special properties, which we'll be exploring in the next slides. And there are like different ways to create a qubit, but eventually everything is same. So it's similar in building out a bridge. They can be constructed differently with varying strength and weaknesses, but also have the same purpose. So let's talk about like different properties that qubit have. So imagine like you have three pennies in the world, and it will be like if you have a coin, it will be like a head and tail head and tail, right? So given a coin in classical computing, we can tell it that it will be head or tail. It cannot be at the same time, right? Both. But if you look at the three pennies at the same time, they can be in the one unique order. Like so, we have three coins, and it can be in the possible state of eight. So it can be head head tail, or it can be like head tail head. It can be either in one of the state, right? But in quantum computing, we have like each pen is in both states. So we have a property called superposition. So given a qubit can be in a state of head and tail both at the same time. So if I look at a if I look at a bit, it can be head and tail at the same time. So all these unique orders can be seen at the same time. So all these pennies, I can see all eight combination at the same time, rather than seeing a one combination in classical computing. I can see all the eight possible combination in one shot in quantum computing. This is the power of superposition. I'll talk about the exponential speed up, like how we get exponential speed up. So if in classical computing we have like two bits, so what will the possible combination? It will be like we have like four possible combination, and if we have four bits, we have like 4:2. We have like 16 possible combinations. But in quantum computing, we have the given number of bits. We have like exponential speed up. So it's like for n qubits, we have 2 raised to n states. So in quantum computing, I need to run program only once to get all eight states, and thanks to superposition. But in classical computing, if I want to see all the eight states of coin, I need to run the program eight different times. So this is like exponential computing power that we get from quantum computing because of superposition. Now I'll be talking about the second property of entanglement, which is like a very weird property, but it's there. So if there is a coin and it says like I'm head. So remember how I said like quantum mechanics can be weird, right? This is one of the weird thing, and it is hard to describe like what's going on. But even like Einstein was surprised, and he called it a spooky action at distance. So essentially, we take two qubits and we entangle them. We correlate them in some ways, and we keep the qubits apart from each other. Even if you keep apart from universe apart, still they will be like correlated. And even after they have been separated, when you observe, you learn something about the others, no matter how far it is. So it says like, yeah, me too. I'm also head. So there's some property like we entangle it, and even if we keep like universe apart, we know like what the other qubit will be. So it is this property is called entanglement. So what like till now whatever I speak, like I just want to like recap of it. So Quantum computer use special bit of data called qubit, which follows the law of quantum mechanics. We use this law to our advantage, enabling us to put qubit into superposition or to create entanglement. Using these techniques, we estimate a quantum computer would require only 160 qubits to model caffeine, which is much more manageable than 10 raised to 49. I'll pause here to take some questions if Aishwarya you want to take some questions.
Hi, hi Sanjay. So
Yeah.
yes, so you were mentioning about the speed of quantum computing, right? Like on
Yeah.
how fast it can do the processing.
Yeah.
So at this point in time, like what, like I do know there's a lot of research going on in quantum computing in various different companies, but what is like I want you to like probably shed a little more light on what is stopping it from being more used, like used more widespread. Why is it not used in production, or why is it not used in the industry as much?
Yeah. So currently, like we are little bit like a few years ahead of like a few years. Like we need still few years to make quantum computing accessible for a commercial application. So talking about like advantage of quantum computing, we right now we don't have any application, much applications that can take out the quantum computing advantage. Few of the reason that I want to mention is like quantum errors. Like qubits are very fragile, so it get affected by even a small amount of noise. So we have a lot of quantum errors right now, which is like we are still trying, like day by day we are still trying to like make it out better. And quantum computing have like certain algorithms, and we have use it for special purposes. So we cannot use a quantum computer for like multiplying two numbers or something. We have like certain applications that quantum computer can use, but currently we are limited by some sort of hardware where quantum errors are there, and we need to figure out more on this. And this quantum errors I'll be taking out in the next like in the practical session, where I'll be coding out a quantum circuit and telling you like what I mean now. So we are limited by some ways, and we are still working out, and I believe like in few years we might have a quantum advantage.
Awesome.
Yeah.
And about Qiskit, right? This is something that anyone can try out if they want to test out quantum computing
Yeah.
stuff, right?
So yeah, Qiskit is like publicly available to everyone, so it's accessible. I'll be teaching out how people can use Qiskit in the live session. Yeah.
Okay, awesome, awesome. That sounds good. Yeah, we can continue with the session.
Yeah. So now let's look at like how a quantum computing looks like. So quantum computer at IBM looks like a big sandal. It's like full of cables and sending data and maintaining the environment. So it's like we at the very bottom. This is like quantum processing bit. We have about a like stem size. So actual quantum chip is very small, and it's like size of a stem. So if we zoom out, this the chip that I was talking about. It's like you can see the different part of chip itself. The dark blue squares are like qubits, are like quantum pennies that we talked about, and the squeezing lights are microwave resonators, which is how like pennies talk to each other, and the computing sends instruction to it to work properly. So this qubit to work properly, it needs to be very cold, colder than the outer space. So it's like 0.01 degree Kelvin. We have to keep this qubit to make this chip operational. So that's why if you look at a quantum computer, you will never see a quantum computer open in any space. It will be always in some kind of chamber, which is called as dilution chamber, to make that environment cold enough to operate. So you will never see a quantum computer lying outside of some zone or something. It will be always enclosed somewhere, because we need to maintain the temperature, and it's very fragile, and we need to make it like there is no noise and everything destroying the qubits. So now there was like a common question, like if it's maintained at so-called temperature, like how it is accessible by classic computers right now. Like quantum computer need to be accessible, right? So here is one of the video that I want to present, is like how the quantum computer is accessible now. So using our classical computers, we are able to code the circuit, and this circuit we are sending out to IBM systems. The IBM systems convert the circuit into pulses, and then these pulses are being sent out to the quantum computer. The quantum computer then we runs a circuit on pulses, and it processes the result. The process is in terms of like pulses, and these pulses are again sent back to IBM systems. The IBM systems again convert the pulses into classical bits, and the classical bits are presented on your screen. So this is how we are able to like make quantum computer accessible to everyone because of cloud. Now like someone might talk about like what is the future of quantum computing. So we have a number of applications that are coming out, but yet we are like not in a particular that much state that we can fully use it. But yes, we have like a future of quantum computing, we have, which is not limited to the slide. So we have like in finance we like do portfolio optimization. Quantum computing, one of the application is like optimization. We can look at a number of ways in one shot. So we have like portfolio optimization, random searches. Like in one shot, we'll be able to get a speed of O raised to O of n raised to n root n, because it's like Lower's algorithm. We have like quantum speed up in like searching out a element in a table. And we have like chemistry molecule simulation, where we'll be able to perfectly simulate a molecule of chemistry. And then there is like machine learning, which is like a growing field right now. If you Many of you might have heard about quantum machine learning coming up, which is one of the application of quantum computing. And second is like RSA encryption, where we are able to like figure out like period finding. And then there is like quantum tunneling optimization. So this is like some of the applications of quantum computing, where I see the future of quantum computing. Now let's look at some of the basic gates that we have like quantum computing. So similar to classical computing, we have like AND gate, NOR gates, right? So in quantum computers, we have the same gates. So it's like one of the gate I will talk about is like poly X gate. It flips the qubits from 0 to 1 or vice versa. So if you think about this poly X gate in classical computing, we have like X gate, right? It flips like 0 to 1 and 1 0. Same we have in quantum computing as well. And one of the like the gates have like certain different responsibility, and they have like certain different performance, like apart from classical computers. So we have like Hadamard gate. It basically puts a qubit into superposition. As I talked about superposition before, right? It will be like a head and tail boot at the same time. So we use a gate to make the qubit on that state. So initially qubit will be either like it will be in a zero state, but to put it into superposition, we need to put a Hadamard gate in front of it, and then it will be like in a superposition. So we have a gate for it. And then we have like C not gate, control not gate. And this is also like available in classical computing, I believe. Like it's like it flips the second bit only if the first qubit is one. So we have like a target and control bit. So depending upon the control bit, if it's one, it will flip, and else it will not, else it won't fit. So we have like similar kind of gates in quantum as well. So whenever like you start practicing any programming language, whether it's C or Java, you start with a hello world program, right? But in quantum computer, if you want to learn a quantum computer, and first program, if you want to think about, like it's not a hello world, we call it as a bell state. So this is our hello world program that we built out on quantum computer, like anyone is starting to learn. So it's like bell state are like specific quantum states of two qubit that represents the simplest example of entanglement. Remember I talked about entanglement, where like a one head tells like another head like, yeah, I'm also head. So it's like entanglement. So this is like a simplest example. Bell state is called as a simplest example for entanglement. It has like superposition as well, and a bell state as an entanglement as well. So this is a circuit diagram of bell state. So H gate puts the first qubit in superposition, and the C naught gate flips both and does not flip both on the second qubit. So depending upon like Q0, if the Q0 is 1, it will flip the bit, and if the Q0 is 0, it won't flip the bit. So it's like more or less C naught gate operation. Assuming the qubit starts as 0, when measured, they will be either in 0 0 or 1 1, but never 1 0 1, 1 0 0 1. So before moving out to like actually coding out a quantum circuit, I want to pause for questions. Yeah, sure. Let me know if you have some questions, or I'll move out to practical sessions.
Yeah, there are like two questions which I thought I can just mention to you. Just give me 1 second. Okay, so let me just put this on the screen so it's helpful for you to read through there. So Arkan is asking when the quantum will become commercially available, and if it's gonna like so basically, like what he's trying to see here is how would it programmatically change the things that we have? Like, would it require people to learn a new stack of programming languages? How hard would it be? Uh, how hard would it be to integrate quantum computing with the existing technology that we have? Like, if you have to integrate applications to it, or like if you want to change things in the infrastructure side, how difficult or easy would it be to integrate quantum computing with the existing stack that we have?
Yeah. So as I talked about quantum advantage, we are actually in a very early stage of quantum computing. We are not in that much state for a commercial application right now. But yes, we don't need to like learn about like new technologies on, because all entire quantum computing is based on Python. So as I give the like live session, like on a practical session, like how will you building out. So we have like a normal module that is used in Python, like how you do pip install some module, right? So Qiskit is also a Python module for quantum computing, which you need to install, and you can just code it out with the Python. So you don't need to learn a new technology stack for being a quantum computing. You just need to learn Pythons and like a certain linear algebra, and you don't need to learn something new. and you will be seeing in the news in the next slides.
Okay, awesome. So yeah, that was another question that we had from Shubham to about like what are the skill sets that somebody needs to enter like into quantum computing. Okay, so there's another question that we have about how quantum computing has an overlap with machine learning field. So what's your thoughts on that?
So it doesn't have any overlapping or something. It's just like we are trying to learn, trying to like run the quantum algorithm, machine learning algorithm on quantum computing. So it doesn't have any like overlapping. The classical machine learning is on their own path, and the QML is on own path. It's just we are trying to integrate like certain machine learning models on quantum computers. So machine learning usually run on CPU and all everything, right? So what we are trying to run on a quantum computer. So it doesn't have any overlap, but it's just like the computing hardware we are changing, and we're
Okay.
trying to like encode a lot of data into quantum computer and decode it. So yeah.
Okay, that totally makes sense. The other question that we have is, does quantum computing have any cost challenges so far with respect to productionizing it?
So right now we have like a quantum computer which is like publicly accessible and which is free of cost. So
Mhm.
right now we don't have any like cost for a normal public, normal people to use it. But
Mhm.
if you go about like a higher qubit machine, then it will be the cost effective. But right now we have a lot of machines, a lot of quantum computers available free to for the people to learn. Because what I believe, like and we at IBM, like it's like we are in a very early stage of quantum computing, and we are building out a community to learn, because we need people to solve big problems, right? We are in a very big problem that quantum computers are able to solve, so we need a lot of people to learn and contribute to the community. So we are trying to build out a community, and that's why like we have a lot of free quantum computers which is
Awesome.
available. Yeah.
Makes sense. Makes sense. Yeah, I think you mentioned that you will be going through the skill sets
Yeah.
uh, to get into the quantum computing field,
Yeah.
right? So yeah, that's I think so far, and the other questions are regarding that. So for people who want to know about the skill sets, Sanjay will be addressing those in the next few slides. So
Yeah.
hang in there. Awesome. And I think people were asking if the slides will be shared. Yes, the slides will be shared with you. And I will also be sharing the recording. So all the conference days are being recorded and it'll be available on YouTube. So you can go check out my YouTube channel. You will have all the session recordings there. So awesome. You can continue
Yeah.
with the session.
So, we'll as I explained about the quantum gates and the Bell state diagram, we'll be actually building out the quantum circuit, and we'll be seeing how we can code out a quantum circuit and send it to real device and everything. So let's begin with the practical session. And so I will go into quantum experience. Everyone is able to see my screen, right?
Yes, it's visible. Let me make it a little, I'll make your screen look a little bigger. Awesome. Yeah.
Yeah. So we have like two ways for coding out a quantum computer, or like we have to install Qiskit, and we can do it by two ways, either locally or from this website. We have like platform for this, and it's called IBM Quantum Experience. And so we can do it locally as well, but I would recommend like doing it on this, because we have like all the packages installed. So I did from here. So here we just need to everyone who is learning Python and everything might be aware of the Jupyter Lab. So we just need to make a new file of this. So it's more or less like a Jupyter Notebook or a Jupyter Lab. So for learning quantum computing, we don't need to like learn a new language or something. We have integrated everything in the Python, and so let's begin it. And as I code it out, you will be understanding like how easy it is. So similarly to how in Python you just import the modules, right? Here also we'll just import the modules. So from Qiskit, we'll import all the modules, and then as I explained about the Bell state, right? The Bell state requires two qubits, right? So we'll be building out a two qubit circuit, and it will require like two quantum registers and two classical registers. And classical registers are required for storing the quantum results. So we'll make two quantum registers, two, and then we'll make two classical registers. So And now to make a quantum circuit, we just need to have this statement. It's like quantum circuit, and where we'll be passing out the classic quantum registers and classical registers. This is spelling error. So at any moment of time, if you want to see like how your quantum circuit is building out, you can just draw the circuit. So it's just the statement. So now we can just draw the circuit like whatever we are building out. So as I mentioned, it's like a 2 qubit machine, and we'll be using like 2 qubits and 2 classical bits, right? So this is our actual circuit that we are building out. So in the bell state, as you remember, we'll be first putting out a header mart gate. So we can just put like qc.h. H is a short form of header mart gate, and we're putting on the qubit 0. So it's like 0. And this we have put the gate. And now again, at any moment of time, if you feel like you want to see the circuit, you can just do qc.draw. And here you can see like we have a hard gate on Q0, right? And then again, as you remember from Bell State, we have like C naught gate. So we'll be putting out C naught gate, QC.cx. CX is a short form from C naught gate. And we'll be putting out our control bit on Q0, and we'll be putting out a target on qubit 1. Again, we'll just see how the circuit diagram is going on. We'll again do a draw. And here you can see we have put a C naught gate on Q0 and Q1, right? And now again, if we need to run this circuit, we need to measure somewhere the output of this result, right? So we'll be measuring out this results on the classical bit. So for measure, we can do just qc.measure, and we'll be passing out quantum register and classical registers. And again, we can do qc.draw. So as you can see the circuit diagram, we have built out a circuit diagram and we are ready with the quantum circuit. So how simple this was. You don't need to learn anything new. It's just a Python you need to know, and Jupyter Lab is somewhat like an extension of Python. It doesn't need to have some special skill set or something. It's just a Python. So as you can see, we have built out the quantum circuit. So now we'll be running this quantum circuit. So we have like two things, not a two stage, but we have like two things. So before sending out this circuit to a real quantum device, we actually run this on a simulator, so that we are pretty much confident that we are sending out a like a correct circuit to the quantum device, and not a like a broken circuit or a circuit that doesn't work. So we'll just run this circuit on a simulator and see how the circuit works. And if the circuit is correct and we are pretty much confident about it, we will be sending out to the real quantum device. So now we'll be taking a simulator which simulates a quantum computer. We can just take from AER. We will take AER simulator. How to run the circuit? We can just use this command. It's like execute, where we'll be passing out our circuit, which is QC, and we'll be passing out the backend, which is as of now our simulator, right? So we'll be passing out a simulator. So now we have run the circuit, and now we need to display the circuit, right? Or whatever the counts and the probabilities we have got. So for we can take the count in a variable where it's like run dot result dot get count. Now for plotting, we need to import for visualizing it, we need to import a histogram. Take it from visualization model, import histogram. So now we'll just pass on our counts to this plot histogram, which will be plotting out our result. Plot it out. So here you can see it out like we have run the circuit on a simulator, and this is the result that we got. So as I mentioned on the Bell state, it is a proper state of entanglement, and you can see 0, 0 and 1, 1, right, on this state. And it is like approx 50% probability that we'll be getting 0, 0 and 1, 1. So this is a classical example of superposition entanglement that we have got. So this is like a probability, and it will be always 1, and we have like 50%, almost 50% probability for 0, 0 and 1, 1. But we never has a probability for 1, 1, 0 or 0, 1. So now we are pretty much confident about like how our quantum circuit is correct, and we are ready to send it out to the real quantum device. This was just run on a simulator. So now for accessing a real quantum computer, you need to follow these steps. So we'll be first loading out our IBM account into account, and then we'll take a provider, ibmq.getProvider, which will be ibmq. Once you have the provider, again we'll take a backend. But this time we'll be taking the backend as a real one. So it will be like provider or get backend. We'll be taking ibmq underscore this device. Now we have the backend, and again to run this job, we'll again use the same instruction that we use. We'll again execute it. We'll pass on our quantum circuit and we'll pass on the backend, but this time we'll be passing out a real quantum device that we have taken from the provider. And now, as you can see, this job is in like job is still executing. It's not still executed. So because this circuit is being sent out to real device and it will be like validated and queued and everything. So for monitoring the job status, we have another module we can import it from. So we have qiskit.tool monitor import job underscore monitor. So in this job monitor, you just need to pass on your circuit. You just need to pass on your job to see where it is exactly right now. As you can see, the job status is queued. So you mean like as you see, like this is like a free quantum device. So a lot of people are trying out to like build out quantum circuit, and a lot of people are just sending out the circuit to run our quantum device. So as of now, the job has been validated and it's been queued. So queued means like there is the you are like two circuit behind where the other people are like in front of you. So to avoid like time difference, like to save some time, I have already like made a backup session where this might take some time, but I've just made a backup session where like I have run this circuit on a real quantum device. So on this you can see the job once the job has been run, it says like the job has successfully run. It's the job status. So similarly on our Jupyter notebook also we'll get the status, and once we get the status we can again just do results and get the counts and then just plot on the histogram. So this will be the result of the actual real quantum computer, which differs from the simulator, right? Now you might be saying like, what is this 0 0 0 1 and 1 0? You told like there will be no possibility for 1 0 and 0 1. So this is what somewhat called as quantum errors. In the previous some other questions, Aishwarya mentioned like why we are not in a that much state or something. So we have one of the reason is like quantum errors. Quantum qubits are very fragile, so we are still figuring out like how to reduce the quantum errors. So this is 0 1 and 1 0 is called quantum errors that we have right now, and it's like as the technology is improving, we are like improving this quantum errors day by day. But one can make out from the probability like 0 0 and 1 1 will be the actual results, right? Because it's higher than others. So this we can ignore, but yeah, one can make out that the result is 0 0 and 1 1. So this was the actual circuit that we have run on a quantum computer. And for this platform is a special access or something, you want IBM Quantum Experience and you need to create an account. You just need to create an account and you'll be able to like play around with the quantum computers. So you don't need like a special access or a special knowledge or something. You just need to like be familiar with some of the basic of quantum computing, and a Python language is needed. Anyone can learn this circuit, right? I don't think it's like too much difficult to learn a new stack or something. So as you can see, I got a notification like your circuit has been run, I think. So now it seemed like the your job status has been run successfully, where it was like this same. Now again, like if you even if you print out, you'll get a similar kind of result like this. So this is somewhat quantum errors that we are still like making out it. So this was pretty much about this session of the live demo. And let me know if you have any questions about the this practical lab session. I'll answer it.
Awesome, awesome, Sanjay. So, yes, I wanted to again like check with you that the quantum lab UI that you were using to run, is that something that's freely available for
Yeah,
people to
yeah.
use? Okay, awesome,
I can
awesome.
share the link in the chat if you want.
Okay, awesome. So what I'm planning to do, right? Like once you are ready to share the PowerPoint presentation with me, which you used for the session today, just share some like reading material, because I think we have had a questions about if you recommend any kind of courses or like YouTube playlists or links that they can from where they can learn quantum computing. So if you have any like resources to any kind of courses or reading material, do share that with me as well. So I'll add that to the description of the YouTube video once this goes on there. So yeah,
Yeah,
and even for the quantum lab, if you can just share the link with me on
yeah,
how to
I can share.
access it and any kind of like documentation. I think it would come with some documentation on how to
Yeah,
access it. So yeah, if you can share that, I will add that to the description, and that's something that the audience can access. And yes, I will share Sanjay's profile with you guys so you can connect with him. Just give me
yeah.
1 minute.
So on LinkedIn, actually, like if you want to look, are you looking for like starting with quantum computing or something? So I have written an article on LinkedIn where I have mentioned like certain materials where people can freely access it and they can start on a free basis. Like you don't need to like spend money to learn quantum
Yes, so
computing.
you
Yeah.
Okay, awesome.
There's an
Let me find that as well and put it in the
yeah.
link. Um, Connect.
And it's like Qiskit module is like freely available to everyone, so anyone can locally install Qiskit and they can be able to like use the quantum computer.
Okay, awesome, awesome. I'm just looking for your article here on LinkedIn. Um,
Or I can try to find it out.
yeah, yeah, I think I found my journey, my quantum journey, right?
Now, it will be there will be one more like how to get started at free of cost. There will be one article on that.
Um,
There will be one more article how to start quantum computing at free of cost.
Let me just quickly check. How to learn and get started. Yeah,
Yeah.
I found it. Awesome,
So
awesome.
this article have like Qiskit textbook. So Qiskit is basically one of the textbook also that you
Mm-hmm.
can do. I can share that as well. So Qiskit is a
Yeah.
textbook that is like freely available where like learn quantum computing using Qiskit.
Okay, awesome.
So this
Uh,
have like everything that I explained, a lot of things that I explained today in this, and how to install like everything, and lot of, and it has like, and the good part is like it has prerequisites as well. So you need to like if you want to learn Python or something, you have like Jupyter notebooks and everything
yeah.
prerequisite. So it's a
Awesome.
like one stop solution. Yeah.
Awesome. Awesome.
Yeah.
That sounds great. So, yes, I have added this in the comments of the video here as well, but I will also be adding this in under the description section in YouTube. So, anybody who's probably viewing the recorded session from today's conference can check that out.
Yeah. And
Awesome,
yeah,
awesome. Thanks a lot, Sanjay. This was very, very helpful, and this is probably a very rare topic, right? Like, we
yeah,
haven't really had a lot of speakers or like a lot of information around quantum computing. So it was very helpful that you came and showed us a demo as well on how to use it. So I hope that clarifies a lot of your questions about what is the skill set needed to get into quantum computing, and if you would need to learn a new stack, etc. So I feel like what you shared in the demo, it was pretty similar to using Jupyter notebooks, right?
yeah,
So that sort of like clarifies a lot of questions here. So if you guys would want to learn more about quantum computing, and then definitely get connected with Sanjay on LinkedIn. I've shared his link here. So let me also show this on the screen. So this is Sanjay's article, which you can check out in the comment section of the live video. And this is how you can get connected with Sanjay. So both of this is available in the comments, so you can definitely check that out. Use the link to get connected with Sanjay.
yeah.
Awesome, awesome.
And like,
Thanks a lot, Sanjay.
lastly,
Is there
lastly,
anything else you would
yes,
want
yeah.
to discuss?
Yeah, I just want to discuss like don't limit yourself to like learning quantum computing. Personally, I'm also from like so I have like this slide which says like anybody can learn quantum computing. So personally, I'm from electrical and computer background. So I don't have any physics degree or something, but if you want to learn, you can learn quantum computing. It is not that hard. So don't limit yourself to a certain degree or something. You don't need any degree to start quantum computing. You can learn quantum computing, and it's like we are in a very early stage of quantum computing right now, and we need like people to solve certain problems, right? We are like the problems are very big, as I explained on the slide. Like we have to like do a lot of stuff, and it's like difficult problems, so we need a lot of people to help in quantum computing and make it possible. So
Yeah.
we are just building out a community and everything. But just I want to say that just don't limit yourself to learn like you need a physics degree or you need a math background or something to learn quantum computing. No, you can learn quantum computing. There is a lot of people who are learning quantum computing without any degree or something of physics or math or something. So I want to say like anybody can learn quantum computing. Yeah.
That's awesome. Thanks a lot, Sanjay.
Yeah.
That was really, really helpful. And of course, like if you do have any reading material, share that with me. So I'll put that out for everybody to go through. Thank you again. Thank you so much for being here and sharing all this information with us. This really is very helpful for a lot of people who don't know much about quantum computing and they are interested to get into the field.
Yeah,
So, thanks a lot, Sanjay. It was great having you here.
yeah. Thank you for being me. Thank you. Bye bye.
Bye.
Take care.
Awesome. So, everyone, I really hope this session was helpful for you and you could get to learn something new. Or if you already were interested in quantum computing, I hope this was informative for you. If you want to get into this field, as I mentioned, like I've shared the link on the comment section, you can go through Sanjay's article and learn more about it. So, before we jump into the next session, which is going to be very soon, so I wanted to introduce the day 4 of trivia. So, let me quickly share my screen. So, as we have had this in the past 3 days, today is the fourth day of the conference, and we are having yet another trivia question. So, what I'll be doing is I'll be showing you a question with four options. One of the option is the right answer. So, I would expect you to put in option A, B, C, or D in your comments on the LinkedIn, and based on whoever answers the question and is the fastest to answer the question, will be receiving a book of Between the Spreadsheets by Susan Watch. So this is a great textbook. So I actually got it to review from Susan, and I found it was really really interesting because it focuses a lot on data pre-processing and what are the different tools and technologies available within spreadsheets or within Excel that can be used to do so. So it does talk a lot about theoretical data cleaning and pre-processing as well. So I found it to be very interesting, and it also points to like subtopics within data cleaning which we on a daily basis might be ignoring, or like might not be paying so much attention to. So it's a great book, very small, thin book, and it's a very good read, very crisp and precise. Covers a lot of interesting topics. So that's why I wanted to collaborate with her again for Illuminate AI's conference, so I can get an option to give those books away to you guys. So not gonna waste too much of my time. So now I'll present the question. So the question is, which of this does not use AI? So the question is, which of this does not use AI? Okay. A, voice assistant. Two, automatic washing machine. Three, a driverless car. Or four, face detection on phones. So put in your choice as A, B, C, or D in the chat. I'll hold on for next 10 seconds and then we can go check who has won the trivia. Okay, awesome. So the answer is, of course, automatic washing machine. We see voice assistants, driverless cars, and face detection, of course, has AI technology embedded to it. So automatic washing machine is something that does not have AI. So, yep, that's the answer for today's question. Let's quickly see who has answered it correctly. I might have to go to LinkedIn to see the chat because on Restreams I really cannot go all the way up. Okay, let me quickly see here. Have to give me a minute till the time I scroll all the way up. A lot of answers, so up might take me a minute. Okay. Okay. I'm here. Okay. Mm, Why would it not show me the entire history? Give me 1 minute. I need to figure something out here. For some reason, it doesn't let me load all the comments, which is very weird. Hmm. Okay, yeah, for some reason, it doesn't let me load all the comments in here. Mm, let's see. Let me give it one more try on getting all the comments in here. No. Interesting. Check on the posts. Okay. Okay. So, okay. So I think the person who's answered this fastest, Shubham, of course, you did win the trivia question yesterday. So um, the second person who's answered this quickest is Manish. So here you are, Manish Kumar Singh. So it would be great if you can just send me a LinkedIn request or a message so that I can connect with you and share the book with you. So congratulations. I am unfortunately not able to see your comment on the LinkedIn side of things because yeah, it's not loading all the comments for me. So but I could see your comment on Restreams, and that's when I found that it's you. So congratulations, Manish, and awesome. Just send me a connect request or a message so I can connect with you and send you a copy of the book. Awesome, awesome, amazing. Let's now take a quick break. So let's meet after 12 minutes exactly. So we'll be starting our second session. So that'll be with Dr. Beverly Wang, and she'll be talking about NLP applications in healthcare. So Beverly Wang will be talking about her experience in healthcare and how she's been using natural language processing and other AI applications in healthcare. So stay tuned. Let's meet after 12 minutes. And if you have any other questions so far, please put that in the chat. So till then, I'll see you. Hi everyone. I think there has been some issues with the loading with like the comments being loaded. So because of which I don't think I'm able to see Sanjana's name, but a lot of you have pointed out. So I'm just gonna put this here. Um, point it out. Um, So Sanjana Jain, I think, yeah, a lot of people have pointed this out, so I would trust your word on that. I am unfortunately not able to see it, so let me just check this out. Sanjana Jain, okay. Okay, awesome. Congratulations, Sanjana. You will be receiving the book. Awesome. Um, Awesome. So I've just tagged you, Sanjana. Please connect with me so I can share a copy of the book with you. And I apologize, I'm not able to see the entire comment section from LinkedIn's end. So I all I could see was the screenshot that I posted with you guys. So I really apologize for that error. So Sanjana, congratulations on winning the book. Awesome. So let's go ahead with our next session. So let me bring upon our next speaker. Awesome. So we have here Beverly Wang, who is a data scientist in IHIS, which is Integrated Health Information Systems. She's from Singapore and she holds a postdoctorate degree in applied economics from University of Minnesota and a master's degree in economics from Duke University. And she has a bachelor's degree in finance from Nankai University. So it's a very interesting profile. Beverly, thank you so much for agreeing to join us for today's session. I'm really excited to host you here and wanted to learn a little more about your work. Like you've been working in the healthcare field and you have such a vast experience in finance and economics. So wanted to learn a little more about you and your work.
Thank you, Ashwarya, for the introduction and for the invitation. And thanks everyone joining online. So I'm very honored to be here. So about my current work, I'm data scientist at IHES. And I will introduce what IHES does later and also the role of IHES in healthcare because I guess many people know what IHES is. So I will introduce that later. About my job, the major part about my job currently is to collaborate with the government agencies and also the hospitals to identify their needs and also to explore the data-driven technology to help them in better decision making.
Mhm.
And the other part is more related to data engineering, so to such as like to improve the quality of healthcare and also to help in model deployment. So that's my current job. Before I joined IHES, I was doing research in the area of behavior and environmental economics. So if you see my background, I'm economic background. I got my PhD in applied economics. So honestly speaking, healthcare is a new domain to me. So
Mhm.
I need to learn a lot of new things when I change my career to healthcare. But I
Mhm.
would say it's not that kind of shocking or kind of quite a difficult thing because actually methodologies are similar in research and analytical works. And my previous research experience does help me in this kind of transition career. Yeah,
Awesome. Awesome.
thank
That's
you.
that's really amazing. So
Mm.
yeah, let's not waste too much of the time and we can jump into the session. So one of the other things I can suggest is Beverly, if we can take a pause after say every 7 to 8 minutes, and I will
Mhm.
go through the comment section and I will pull out the relevant questions for you and I'll ask you those questions. So it'll be great if you can just take a pause after every 7 to 8 minutes so we can be more interactive with the audience.
Okay, no problem.
Awesome.
Thank you.
Awesome.
Let me
Let
share
me
my.
know once you want to share your screen.
Okay,
Awesome.
yes.
Yes,
Okay,
we can see it here.
okay, that's great.
Do you
So
mind
in
seeing it on full screen, like on slideshow?
so, uh, is it? Can you see my screen?
Yeah,
By
I
the
can
way.
see your screen. It's not on the full screen mode. It's not on the slideshow mode. Can you click on slideshow and check?
Okay, let me see slideshow.
Yeah, awesome.
Okay.
Oh wow, it's still not showing the full screen for some reason.
Um,
Are you using two different screens? Are you using like one screen in your laptop?
uh, one screen, one
Oh, interesting. That is
something
weird.
has a back. Well,
Can you click on escape? Escape key? Let's try this one more time. Okay.
okay,
Okay, let's try this one more time. So can you see this funnel kind of a symbol at the bottom right corner?
right corner, which one?
Let me.
This
So
one.
so you'll be able to see this bottom right corner. So you see the minus
Mm,
symbol just left to that.
this one.
Uh, you see the minus symbol, right? On the bottom corner. Yeah, interesting. For some reason, it's not showing up the full screen. Do you
Oh,
mind closing the presentation and opening it up again? Let's
okay.
let's
Yeah.
try to see that if that works.
Sure. Let me see.
Thank you.
Mm, sure. No problem. Well, somehow it still look like this. Okay.
Sorry?
Uh, let me share. Are you able to
Yeah,
see my screen? Okay.
not yet.
Somehow, not yet. Okay.
Not yet.
Okay. Let me share again.
Mhm. Yeah, now we can see your screen. So for some reason, it's
Okay.
not showing in the
Hmm.
full screen mode.
Yeah. Yeah. Oh, what's happened? Well, I
Uh-huh.
think it doesn't affect the content. Okay. Just a
Okay,
little
so
bit strange to see a kind of wide, like the black a little bit wider.
for you, it's showing in the full screen.
Actually, for me, I don't know. It's also not quite full screen. There's still black on the side.
Oh,
Hmm.
interesting. Okay.
Yeah.
Um,
Well,
can you
I think
click on escape?
mm,
Let's try
escape.
doing this. Let's try doing this. So, yeah.
Hmm.
Can you close the not close? So, can you go to file
Okay.
and export the file as a PDF?
Okay. Let me see.
That might be helpful. I am sorry, everyone, but yeah, I think we have had this problem with another presenter as well, where she wasn't able to uh, view it in full
Hmm.
screen. So let's try to export this as a PDF and then let's try to open it up as a PDF. Does that work, Beverly?
Sure. Let me see. Mm, okay. Okay. Let me see if this can help. Okay. Let me share again. Hmm.
Yeah, sure. Yeah, awesome. Now this is better. Can you also click on the arrow key on the right
Also
side so it closes up?
close this.
No,
Okay.
no, not close this. On the right side, you see the section coming up, right? Which has the convert and like free 7-day trial.
Oh,
You can minimize that. Yeah. So you see a arrow key on the right side, like a small arrow key on the right side.
uh-huh.
So next to
You
the
want
scrolling
to
part, you see the arrow key, the right arrow key.
mhm. Yes. Uh-huh.
Can you click on
Oh,
that?
okay.
No, no, not that. Okay, yeah, you can you
Oh,
open?
this one.
Yeah. So you see
O-
this arrow key, right? Which is near this export PDF and the convert section on the right side.
Okay. Actually, I'm already converted. Uh,
Yeah, you can just
okay.
that's good enough. Awesome, awesome.
Okay. Okay.
Now you
Let
can
me
start
see.
with the presentation. That'll be easier. Awesome.
Can I help? everybody can see it in a good way. Okay, so I'll just start. In this session, I will share a concrete example of AI and machine learning, the application in healthcare. So I will start with a little bit introduction about the role of IHES in health and also the data challenge I feel in healthcare. So let me move on. IHES was founded in 2008 under the background of two trends. One trend is growing and aging population, which makes the healthcare demands grow in scale and also grow in complexity. And the other trend is the advancement in information technology, which expedites the digitization in healthcare. So under this background, IHES was founded, and as it's funded, it's appointed by the Ministry of Health in Singapore to act for the advancement of healthcare IT in Singapore. And now it is the law in Singapore. So every year it has many technology projects ongoing, supported by many like knowledge professional and engineers, solution architects. And it also holds and maintains over 800 systems. And also one advantage of working at IHES is that all public healthcare institution runs on IHES powered technology. So we have a good collaboration. And here are a bunch of the examples that IHES design, implement, and also support. So one of the example is a kind of platform which support the healthcare like analytics of the sensitive data in real time. And some other example is the mobile apps, which enable the people to make appointment with doctors and also to track their health condition. There's also some other like for the telehealth system, which can help people to make a video consultation with the doctor. So there are actually, IHES have quite a lot of engineering and solution architecture to support some kind of function and working in all very, very different areas in order to support the healthcare. And as IHES, the role of IHES is the IT service provider in healthcare. It is also the health tech agency for the Ministry of Health. Given that IHES is actually able to connect in many partners in healthcare ecology, such as the government agency, and also the public hospitals, and also the major groups of clinics. So due to the of IHES in healthcare, we actually have a very good opportunity to collaborate with the hospitals to handle tons of healthcare data and also to explore and deploy the value of healthcare data. Okay, let me move on. So by digitizing and connecting and also analyzing, the ultimate goal of IHES is to improve the population health and also the health administration. So that's what IHES does and the goal of IHES. So let me move on. I'll talk a little bit about the data in healthcare. The data in healthcare is actually large in volume and complex in the variety and also fast in the velocity. And there are heterogeneous data coming every day from the healthcare setting with different content. They can be either structured or unstructured. It includes some classical healthcare data, such as your like electronic healthcare records and medical images, and also clinical notes written by physician or like by the doctors or nurses. So all this kind of information are the healthcare data. And nowadays, healthcare data also includes monitoring data coming from, for example, the wearable device and also the messaging and the pictures you post on social media. So the data actually, the healthcare data generated every day, and tons of them can be used for the improvement in healthcare and also to improve the clinical treatment. So in that sense, actually, the data is very helpful. We are not lack of data in healthcare. So this data has a great power and potential to improve the whole healthcare system. However, the data is not that easy to use as seem to be. And my personal experience and also in my opinion, I feel there are 4 challenges to use the data in healthcare. So the first one is data integration and standardization. This is not just a technical issue. This actually requires a lot of administrative effort to collect data from many places apart, and also to harmonize the data of various type and the various coding scheme. As a kind of first challenge. And the second challenge is data quality, which can never be overemphasized because we all know trash in, then trash out. And the third challenge I feel is data maintenance. For example, data security and data storage, like how we can the sensitive data from the system failure or from the hacker's attack, and also how we store data efficiently so that we can make data searching in an easy way and also in a very effective way. And the fourth challenge is the data insight, and which do require the understanding of the data and also require the exploration of the data value. So especially in healthcare, it does require some domain knowledge to better understand the data. So when I actually think that's a very important skill, like when we see the data, we need some a table of data, like messy numbers. We can actually feel the data. We can visualize what the data is trying to talk about. Actually, that's a very important skill. I kind of think it's a kind of data intuition. So actually, it will be very helpful when we do the jobs in data science. Okay, let me post here to see if there's any question.
Hi, let's see. Just give me a minute. For some reason, there's a lag between the questions that I see on LinkedIn versus what I could see here on Restreams.
Okay.
Okay. Yeah, I think we don't have any questions so far. We're good to go.
Okay.
Thanks, Beverly.
So let me move on. Okay. So for AI machine learning, definitely can help in data insights, and the technology has been applied in many predictive models in healthcare. So we have developed the models called the early warning system, which help to identify the patient at high risk of entering into ICU in next 24 hours. And there's also a model using the chest X-ray to predict the clinical deterioration for patient with pneumonia. This is actually especially important during the period of COVID. And we also have a model to kind of stratify the diabetes patient at different level of risk of CKD progression. CKD is a chronic kidney disease. It's actually one of the serious issue in Singapore. So with the help of this model, we can allocate the polyclinic resources accordingly and also effectively to engage those at high risk of CKD progression in a long-term care plan at their early stage of the kidney disease in order to slow down the deterioration of their kidney function. So this model is actually just being deployed this year, and it's kind of deploying the nationwide in Singapore. So it actually is very helpful. But in today's session, I want to talk about another aspect of AI and machine learning, how we apply it in data management, which has not been mentioned that much before. So I will talk about an NLP model. Actually, it's a simple NLP model for the medication encoders, and I will introduce how we build it and how we use it and how we use that to motivate the other use cases in healthcare. Okay, let me move on. Okay, so let me introduce a little bit what medication data is. So it's important data in healthcare. It basically tells the information centered around drugs, like how you take the drug, where you take the drug, and then when, like what the drug is and who take the drug. So basically, we kind of provide information centered around this kind of 5 Ws. And this information is useful for prognostication and also for clinical treatment. For example, I think you may be asked by a nurse or a doctor something like, do you have any drug allergy, or are you taking any medication at the moment? So all this kind of question is related to the medication. This information is also useful for pharmacy management, like to check the storage of drug and to find a replacement of drug. And it's also important for pharmacovigilance. So since the pharmacist can give proper advice to the patient in order to avoid some adverse effect. So that's how it could be used. However, when we see the original data, medication data in the healthcare system, actually it's very difficult to use because it's free text. Here, this table provides examples. We can see that it's mixed with typo and irrelevant information, and it's not easy to read. As a layman, I really don't know what does this drug means, and I have no idea whether these drugs have a similar functionality or not. And also, even for a pharmacist, it's very difficult and very efficient for them to read tons of record like this in order to find some drugs with similar functionality. So like the medication data is kind of free text. It's not the standardized, which actually limit its usage in the healthcare analytics. Also, we cannot use that very efficiently in the healthcare management either. One way to solve that is actually to use some code scheme, and we do have a code scheme in medication, so that's actually good. You do need to require some domain knowledge to understand what it is. So this kind of scheme is called the ATC, Anatomical Therapeutic Chemical Classification System. This kind of drug classification system classifies the active ingredients of drug according to the organs or the system on which they act. And this classification system are maintained by the WHO. It's a strictly hierarchy, which has a 5 level, with level 1 being most general and level 5 being most detailed. So here is an example on simvastatin. So here is its ATC code. Each drug will have a ATC code. So the first letter C is a level 1, which tells the anatomical main group of this drug. For this simvastatin, actually the first level indicates that it works on the cardiovascular system. And the next digit to tell the therapeutic subgroup of this drug. So here is a lipid modifying agents. I know like this kind of term sounds a little bit alien to those who are not working in healthcare, but actually with some, it's not that difficult to learn. It's just like or kind of Wikipedia to understand that. But I want to emphasize is that some domain learning can really help you to understand what the data is, and also it can give you the insight on how to solve some problems. So here we can use this ATC code system in order to standardize the medication data. And by standardizing the medication data into the ATC, it can make those kind of previously free text medication data easily to use and easily understood by others. So if everything is kind of converted to ATC code, then when next time the pharmacist or some other people want to find the drugs related to the cardiovascular system, it will be easy for them. They can just search the drug with ATC code. Then you can easily search all these drugs and then find the one they want. So this is how it works. Shall I pause here to see if there's any question?
Yes, hi Beverly. So yes, we do have a few questions here. So one of the questions is about how do you tackle with like data governance or AI governance, especially when it comes to medical data, right? Like with the HIPAA compliance, how does it work when you're planning to work on a particular use case?
Okay. Yeah. So normally, uh, so actually this, I think this is one of the benefit like working at IHIS, because IHIS has a kind of close collaboration with the hospital. So
Mhm.
hospital will come to us with their needs. So they want to solve some problems. So they will
Mhm.
bring their problems to us, and we can help them to identify their questions. And in terms of the data, because IHIS is the IT provider to them, so actually, after they grant us, of course, after they need to grant us, give us the access to the data, then we can
Mhm.
easily do the access. We don't need them to like say, can you give us some data separately, buy some fly fat? No, that's not possible in healthcare, because
Yeah.
IHIS is IT provider, so we do have a platform
Mhm.
that can safely access to those sensitive data.
Okay, got
So
it.
that's
Got it.
actually the benefit of the IHES.
Awesome.
Mhm.
And one other question, Beverly, is when you're the data that you're using, right? Is it local data? Is it like, only Singapore constrained data, or is it global data?
The data actually I'm using is Singapore data, the
It's only
nationwide
Singapore data.
data.
Okay.
Yes.
Okay, got it. So I think Mike, that sort of answers your question. So Mike was asking, how do you handle different drug names? Because same drugs, like the chemical formula could be the same, but then the different drugs could be named differently in different countries. So he was asking, is there any international standards that you follow when you're trying to build the models?
Yes. Yeah. This is Singapore data.
Okay, awesome. So yeah, Mike, as it's only containing one country's data, Beverly's mentioning that there's no like conflict of different drug names. Awesome. And Beverly, another question. So whenever you're using when you're training models on healthcare records, especially, right? So what kind of challenges do you currently see that in the medical field that comes up when you're trying to productionalize these models?
Uh, so I think the question is more about like model deployment.
Yeah, right.
I kind of interpret it in this way.
Yeah.
So to deploy the model, actually, yeah, because it's a healthcare. So once the model is there, we actually need to go to a lot of approval steps. We need to go to the EUC of the hospital, let them to judge whether this model is okay to deploy in the whole systems. So there are actually very strict security rules on which model to deploy, especially when the model is developed using the open source using some open source libraries. So for all the like Python libraries we're using, we do need to go some very strict scrutiny in order to make sure everything is okay. So that's actually one challenge. If we're using the source package and also the Python to develop the model, then we need to go through a very strict scrutiny when we try to deploy this model to the system, into the systems. However, I think there's a workaround way of that. So in the hospital, like when we test the model, we can actually set aside, physically isolate the one computer. So let the doctor use the model first. So once they get familiar, like how this model can help them, actually it will not be that difficult. So that's I'm not sure whether I answered this question. Yeah.
Yeah, sort of. So yeah, one of the things I wanted to understand is when. So what I'm trying to answer is once you say that you're like classifying any kind of values, right? How often is it more of an assistive technology when like there's still some person or like some healthcare staff who's overseeing the results which is being produced by the model? Does that often happen?
Yes, definitely. Yeah, there's also actually for the model, like when we deploy the model, like after some period, there's always some people need to check, even from the ITs internally, we need to go there and check
Mhm.
whether the performance is still stable. If it's not stable, we need to either retrain the model or even redesign the model.
Mhm.
Because like for a predictive model, um, the time trend, there may be some change in the time trend. In that sense, we may need to come back and then retrain the model to make it fit the current trend.
Mhm.
So yes, I would say that after the period, we do need to see whether the model performance stable. If not, then we need to retrain or even redesign the model.
Got it. Makes sense. That makes sense. So another question I think that we have here is, just give me a second. Okay, awesome. Okay, awesome. Yeah, I think that's all the question that we had. So yeah, one more question is about like alternate data, right? Like, do you guys rely on any kind of sources of alternate data when you're trying to like build models, or is it only coming from one source? So do you try to like compare this with any other internationally available data which is open source, or collaborate with somebody else to collect more data, or is it only coming from like one source?
That depends on the case.
Mhm.
So if we're trying to serve more local purpose, like for example, if we're trying to so I would just talk about the model I'm handling with is a CKD prediction, a risk
Mhm.
prediction is try to predict the diabetes patient, their risk level of CKD progression. So this scenario, actually because we are serving the Singaporean and also the people in Singapore. So it's actually in that case we should use the like a local people data to train the model, because that's the group of people we're trying to serve. But say if we want to kind of do some more generalized kind of generalized projects which can be matchable to the international question, then we will go out and search more data. We actually do these things in one of the and in another NLP problem to detect the like a drug and adverse effect to drug and adverse effect from the kind of notes. In that case, because it's kind of more general questions, we do go out and search the international data, like either the notes from the other countries, in order to kind of increase our training data sample, and then to learn not just from the notes in Singapore, but also learn from the notes in other countries. So that's really depends on uh, how this model is going to be used, and who is going to serve. Yeah. Yeah.
Yeah, that makes a lot of sense. So yeah, I think that's all the questions so far. So yeah, you can continue with your presentation.
Okay, thank you. So let me just continue. So since we know the solution to standardized medication data, so I would say that previously what we use is the mapping and the manual mapping to standardize the medication data to convert it to the ATC code. However, this kind of methods cannot solve the complicated scenario in the free text, because like a multiple medication name, there could be multiple medication name for the same drugs. So here's the example. These two texts looks quite different, but both of them refer to the same drug. So for this kind of issue, table mapping and manual mapping, it'll be quite difficult for them to handle this, and it requires a lot of effort to do so. And another scenario cannot be handled properly is misspelling. So here's another example. And the third scenario is that all the tests in the medication we collected are relevant. So here are some irrelevant information in that data that we need to consider. So in general, the previous method to process and to standardize this data has two limitations. So one is the accuracy problem. the mapping table need to be maintained and updated frequently in order to capture all the variation in free text. And also the exact mapping or regular expression cannot deal with the complex or mathematical description. And the second limitation is, of course, efficiency. Manual mapping takes a lot of time. So under this scenario, under this kind of background, we use NLP model to standardize the data. Okay, let me move on. There actually a group in IHES who was previously working on mapping this kind of medication data to ADC code. So they have accumulated a lot of tables, and then they have actually very experienced in the medication terminologies. So collaboration is very important within IHES. So actually they provided us with all of these mapping tables, and also they help label more data for us to do the training. So in total, we collected close to 120 records of label data, which are quite important for us to improve the model and also to have a kind of a model of good performance. And here are some examples of the data we collected. So this is a table we finally will obtain. So we can see that there are some characteristics of the medication data. First, we can see for this medication data, it's actually not that pure free text. It still follows some patterns, although not quickly. And another thing we can see that like many ATC code, like this one, actually have multiple medication items. Also, for some medication items, like this one, they're exactly the same. They have multiple ATC code. This is be caused by the inconsistency of manual mapping, but it's very difficult to avoid that because it's manual mapping. And then also input, we have irrelevant information, which are coded as unknown. So this is how our input data like. For strategy, of course, we need to split them into training set and test set. Test set keep the untouched until we do the evaluation at the final step. And because of the characteristic for our input data, we do some special treatment. So for those ATC code, is a single medication item, we only put them in the training set. And for those with multiple medication items, split them into training and test set using the ratio of 9/1. One, like this 10%, like seems kind of small, but because we have such large, large data set, so even though it's just 10%, but it still gives us a lot of data and enough for evaluation. And also we do upsampling. For those ATC code with a small amount of medication item, we just upsampling them in our training set. Okay, let me move on. So we tried a bunch of models, and here shows the model structure of the 5 model we selected. So in the training step, like each medication item will put through the input layer and then put through the layer. In the embedding layer, we use our customized embedding, which was trained on our medication data. So it can understand the medication content better. And then it puts through this by-LSTM layer, which take care of the words from and also the words at back. And then the final, the output will go through the attention layer, which take care of the dependency of our words. And then we also add some other layers and generate the final layers to give us which is the ATC code we should assign to it. So this is a general summary on the model structure. And of course, here in the model structure, one important thing is the embedding layer. Do not use the pre-trained because it's not that relevant to medication content. So we use our customized embedding. And also the by-LSTM. I think many people know that, like the key component is this LSTM unit. And here shows the logic. So it has a several different types of gates to control what to ignore, what to update, and what to remain for the main memory. And for the attention layer, of course, the attention mechanism is important. It has introduced this kind of three major to handle the dependency of the words and what kind of weight we should put on them and their significance of the informations. So this is how it look like. Yeah. Oh, let me post here to see if there's any question.
I think we're good so far.
Okay, great. So let me move on for the evaluation. So by evaluating on the test data, actually the performance is quite good. The accuracy 99%, AUC close to 1. Of course, like our data strategy and also the model structure contribute to that. But I would say the characteristic of our input data is also an important reason that contributing to such high accuracy and also such high AUC. Because like you can see that it's not purely free text. It still has a strong pattern. So although the text does not follow that pattern strictly, but the pattern is still very strong. We can see that it is not just as pure text as we normally speak. So this kind of characteristic of the data make it easy to learn by the model. So the model can learn easily and to understand the content better. Yes. And then we also do some analysis on the mismatch between the model prediction and also the our label. We found there are actually two scenarios which can make our performance actually this two scenario indicates that our actual performance of model is actually better than. So one scenario is that the caused by the multiple ADC codes for the same drug. So here is some example like these two drugs. In the input data, they're actually being assigned with two ADC codes. And similar for these bottom two drugs, they are quite similar to each other. And they're also assigned, actually assigned different ADC code. So if our model, given in this scenario, give a kind of different ATC code. So for this first one, if it doesn't give the ATC code S, but starting with the J, in our calculation, we'll consider it round, but actually our model prediction is correct. So this one may indicate that the way we calculate accuracy may underestimate our actual performance of the model. And then the other thing is some medication items which are annotated as unknown, they may actually belong to some ATC code. Actually, that shows the potential of our model to improve the current human manual mapping. So here are some example. So for this kind of item, the medication item, in the manual labeling is tagged as unknown. But if we compare with the two drugs, we can find them they're quite similar, and they should assign with the similar ATC code. And then also for this medication item, if we compare with the item two medication item above, they're actually quite similar. Just the bottom one has a bit typo in it. So basically it should be assigned with the same ATC code. However, it's tagged as unknown. So this scenario actually I found is kind of evident to show the potential of NLP model to improve our human labeling. So that kind of gives us confidence in this model. And then let me move on. So as a summary, like even when we use the conservative matrix calculation, our model still achieve high accuracy. So by using the model, we can put in the medication item through the medication encoder and obtain the corresponding ATC code with it. By that, we can standardize the free text medication term into a kind of standardized code scheme, which is easy to use. And I say like through this process, three things are important. The first one is domain knowledge. Like if we do not know the existence of this ATC systems, it will be very difficult for us to come up with kind of meaningful solution to this kind of data standardization issue. And the second thing is, of course, the technical wise. Data strategy, model architecture are important for the model performance. And the third one is a collaboration. Yeah, because there are different groups has already been working on this issue, and there are more experience with medication terminologies. So by collaborating, we actually can have such a huge number of the label data, which can make the model perform better. Okay, that's a summary. And in terms of application, I would say that by using this medication encoder, it makes easier to derive feature related to medication. So we can derive features such as like how many different types of drugs you've been taken in past 1 year, which is related to, for example, cardiovascular system, and also like how long, like what's the average duration that you've been specific medication. So by using that, we are able to generate a feature like this, and it can reflect the one's medication background, medication history, and also one's healthcare conditions. This information is actually important in prognosis and also in clinical treatment. And I would say that we create a bunch of the medication-related features which has already been used in our predictive models. For example, the CKD risk stratification model and also the hospital readmission model. And these two models actually has already deployed in hospital, and then kind of contributing to make a difference, change in the healthcare. And also like this feature has been applied in the recommender of vancomycin titration. Give a doctor a suggestion on the amount of this vancomycin, which is a kind of antibiotic to use for different patients based on their different health conditions. And also like I would say this medication encoder can also facilitate the pharmacy management because it has already standardized the medication data, make it easy to use. So we can easy to identify different drugs and do some comparison. And this encoder can also be integrated as an IT solution to extract the medication information from the notes, from a lot of discharge notes or clinical notes, and to assign ATC code accordingly. So actually in this presentation, I just want to show even like this NLP model is not that complicated, but it can still help a lot. So although only focus on data management area, but you can see that it can also contribute and promotes the research and also other use cases in medication and also in healthcare domain. And I hope this could be an example to you to vividly found the potential of AI and machine learning in healthcare. Yeah, thank you.
Awesome. Thanks a lot, Beverly. So I think we had a few questions here about upsampling. So Partha is asking if we are upsampling data, it would create some duplicate records. And does that pose any kind of challenge for, especially in the area of medical data?
Actually, no. Let me go through the slides mentioning here. Okay. Let me see. So, yeah, I think he's asking this kind of question related to the upsampling. So, yeah, yes, it will create duplicated data, but that we're not upsampling all the things. We're just upsampling the ADC code with a small amount because given that we have such huge amount of data, if we do not do anything there, this kind of ADC code may easily ignore by our models. So it may make our model perform very good on the ATC code with a lot of like examples, but may perform bad on the ATC code with a quite small number of items. So we want to increase the attention of our model to this the ATC with a kind of real data. So in order to enhance our model ability to capture this scenario, so we actually do it on purpose. I'm not. I think the question about duplication, actually that's what we want to do, and we want the model to pay attention to.
Mm-hmm.
Yeah.
Okay, makes sense. Yeah, that totally makes sense.
Mm.
Okay. Um, let's see if we have any other question. Okay, awesome. Awesome. So Sandeep is having a question that what's the purpose of upsampling data with ATC codes that might or might not be mapped correctly?
That may not be mapped correctly.
Yeah,
Sorry.
yeah, I am also not. Uh, Sandeep, would you
Uh,
like to expand on your question? So if you can just expand on your question on what you mean by. Uh, so he's saying that we don't want to duplicate data that are mapped correctly. I'm not sure.
don't want to.
I'm not
Okay.
sure. Yeah, I'm not sure about the question. No worries. I think that's all the questions that we had so far. Beverly, would you be able to share the deck with me, along with any kind of reading material which you can suggest for people to read regarding this topic or with about IHIS? So yeah, that'll be wonderful. So I can add the recording like the recording of the video will be available on YouTube for people to watch who couldn't join us live, and we'll also be sharing the deck that Beverly just shared with us, so you can refer to this content later. Awesome,
Okay.
awesome.
Thank you.
Thank you. Thanks a lot, Beverly. It was wonderful to have you here, and thank you so much for sharing in a really detailed manner. So it was really nice that you actually like shared the internals of the model and like how you train the LSTMs, etc. So that was very helpful. I hope it was informative and insightful to the audience as well. So if you have any questions, please feel free to connect with Beverly. So I'm going to be putting her I will be putting her LinkedIn I will be putting her LinkedIn profile link here, so you can connect with her. Let me just quickly do that. Connect. Okay. You can connect with Beverly here. If you have any questions, you can feel free to reach out to her for those questions. Awesome. Thank you so much, Beverly. It was amazing to have you here.
Thank you.
Have a good
Thank you. Glad to share. Yeah. You have a good day.
So, thank you everyone for being part of this conference. And I would definitely want to know more about your feedback about the conference. So, last year when we hosted the conference, we had one single day of the conference. So, it was about 4 to 5 hours in one stretch. And we got feedback that it was way too long for people to attend on the same day, especially when they are joining in from different time zones. So, it was very extended for them to attend 4 hours of a conference on a single day. So we took that feedback and we split the conference into 4 different days so that people can attend in different days, and it's only like about 2 hours every single day for them to attend. So that way we cut down on the time. So I would definitely want to know more about your feedback. If you do have any feedback on how we can improve the conference, if there are any topics which you guys are interested in which we can host for upcoming events and sessions, please do put that in the comments. And yes, if you have any other feedback about the conference, how we can improve it, how we can grow more engagement, please definitely reach out to me, and I will take your all your feedback into consideration. I really appreciate most of you, holding on to the conference till the end. I think we started off with about like 400 people, and now we are left with about 200. So I think half of you guys could like go through the entire conference. So this is awesome. I'm really glad, and really hope that this was helpful. It was insightful, and you could learn something new. The whole purpose of what we are doing at Illuminate AI is to create awareness around how to share the information and how to bridge the skill gap between academia and industry. So we want you to be aware of how things work in industry, what are the challenges that people face when they are trying to build projects or products in an organization. So, and we are trying to present to you all different kinds of industrial use cases, and not and as I always say that, data science or AI is not just specific to technology industry. It is wherever there's data, there is data science, right? So and every industry has digitized information. So every industry that you are interested in, every industry that has data has an opportunity for you to apply data science. And as a part and parcel of data science, AI comes into picture, because when you're trying to automate, when you're trying to build better intelligent systems, you can use AI, or you can use machine learning. So I really hope the conference was insightful to you. And um, yeah, I mean, I am really hopeful that you will give me some feedback so I can improve this experience for you guys. And thank you so much. And congratulations to all the four winners of the trivia rounds. And you'll be receiving your books very soon. Thank you so much, and have a great day ahead.